Nathaniel here, and welcome again to a little bit of deep learning and Keras, where we learn just a teeny tiny bit of deep learning and a whole lot of Keras. Okay, so we're going to be talking about so we talked about models. Those are the bricks. We're going to be talking about the atoms, the submolecular components that make up. These are the basic building blocks. These are called layers. We talk about deep learning. One of the important things about deep learning is that it's a multi-layered model. If you don't have layers, you're not doing deep learning. So let's talk about layers. So here we go, Keras layers. You've seen these layers before. I'm not going to introduce crazy new layers. Well, not crazy new layers. I'm not going to introduce convolutional max pooling, RNN layers, anything like that. I'm going to stay away from that unless I get enough comments and brute passion for a particular layer, in which case I will do a video on it. Otherwise, I'm just going to show you in general what all layers have and how you use them. The input layer is somewhat special. As I've said before, it just allows you to specify an input shape. That's it. Every other layer kind of acts like a little lambda. So this dense layer, remember, this spits out a function that you can call on inputs. These inputs, we'll call them tensors. Yeah, and so that's kind of what a layer is. A layer is a little function. Now, there's something interesting about the function is that it's a stateful function in a way. So layers will generally have weights associated with them. So it's not just taking some value and multiplying it times 10 and then squaring it or something like a function, like a normal function. We'll talk about how you do that later. But these guys are taking a specific input value and you're changing it based on its state, its internal state, which is the weights that are associated with the layer. So each of these layers will have a get weights. So we can go ahead and run this. Chug, 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 and we get the weights. What? You're like, oh no, there's no weights here. Nathaniel's a liar, bad man. Well, the one thing that you guys may be curious about is where the weights are in a dense layer. Where did they come from? And how do they know what shape to be? So in a dense layer, we have each connection in the dense layer from its input to its output contains a weight. But how do we know what the input to the dense layer is? We don't. We haven't specified it yet. So instead, what we need to do is we need to go ahead and call layer on inputs, right? If we call layer on inputs, this will go ahead and it will initialize its weights. Because previously, it didn't even know what types of weights it would have. So we can call it. Layers, of course, have names. You can specify the names just via like a little name parameter up here. Layers have like a layer class name, which you can get via this. So if you're doing any sort of function that requires you to check out what type of layer is there and then spit out something, that's how you do it. Layers can be trainable. They can be trainable or not. So in this case, this layer has a weight. It has a state, which we call weights, and we can update that state. I really don't want to overload this word state because this is different from the state of an LSTM, for example. But layers have weights, and we can say we can change those weights. We can make those weights mutable by saying trainable equals true. If we make them false, then all those layers in that all those weights that layer have can't be changed. They're frozen. Okay, so we can say it's true, and we can get the weights. And ta-da! There's the actual weights. The magic thing is we can actually go ahead and we can set the weights as well. So in this case, we have the weights of the dense layer, and we have you can call it the kernel of the dense layer, as well as the biases of the dense layer. And I'm not going to go into extreme detail on talking about what this practically means, at least not until we get into the history of deep learning, in which case I'm going to be going into very sort of theoretical things, but because we're learning just a little bit of deep learning, I will fill you in. Generally, these layers will have weights and they'll have biases. The weights will be multiplied to your input, generally speaking, and the biases will be added to your input, generally speaking. So we can change the weights just by using layer.setWeights. So for example, I go ahead and I set the kernel, that's the multiplier, to the exact same thing. And I set the bias to be a new bias. I just give it a 1 here, right? You can prove that this works by looking at the weights, and ta-da, we have a 1. So I can manually change the weights. Generally, you change the weights using training. You'll update all of the weights using training. Okay. Layers have a couple of other functions. They have an input and output, a shape, an output shape. So all sorts of these things. If I make a new layer, so I use this layer twice, what happens? Error. Okay. So this has multiple inbound nodes. So it has multiple outputs, so we can't just specify a single output. Instead, we need to specify output at. Now notice models have all this. Since a model is a little layer, they'll have all these as well. So models have all of these functions as well as layers. So all layers literally have all of these functions, which is pretty cool. The one thing that you need to remember sort of very intensely about layers are little functions. They are little functions that contain some internal state, which we call weights. And these weights are trainable, or they can be non-trainable. And when we fit a model, when we learn from data, we're changing those weights. Okay, so let's get on here. Let's move on. Okay, so we're saving and loading individual configs, layer configs. We can totally do that. We can get the config. So we make a new layer. We grab the config by saying get config, and then we can reconstruct the layer from that config. Easy. And you can just literally, if you'd like to look at the config, there it is. That's what it looks like. Again, it's going to reinitialize all of the weights. We're not saving the weights. What else? And then we can, of course, deserialize a layer. It's just you're using the config, except for instead of specifying dints from config, you can just go ahead and specify layers.deserialize. So I can go ahead and I can pass in the layers class name in order to deserialize this. So pretty cool. Okay, so that's what general layers are. There are two special layers. There's two special layers. One is the input layer. We already talked about that. And the second layer is the lambda layer. Ooh. So the lambda layer is it's any layer that you want. The only thing that's special about the lambda layer is it cannot have internal state, right? It's going to do the exact same thing every time. So for example, and it gets its name from lambda functions or unnamed functions. So for example, we can have a layer that just squares everything. So this is my squaring layer. We can have a layer that is an anti-rectifier. So we can do some BS over here, then we can get the positive parts of the thing, the negative parts of the thing, and then we can just concatenate them together. So we just double the dimensions. So notice we didn't use any weights. This has no state. You know, if I pass it one input, it will always act the exact same on all the other inputs, unlike a normal layer. In which case, a normal layer like dense, it will act differently depending on what its weights are. So we can make an anti-rectifier layer. One thing that you need to note is if you're making very complex layers, you need to specify the output shape. So you have to have a function that will tell us what the output shape is. This sometimes you can sometimes get around this in TensorFlow. It will try to infer what that is, but very complex layers, it gets confused. So, okie doke. And in addition, you can literally just pass in any sort of like TF function in here. So reduce mean, for example, that's a new lambda layer. To power. This is another lambda layer. The power equals 2, so I can specify some arguments to this lambda layer. So again, remember each of these layers is like its own little lambda, it's its own little function. It doesn't do anything until you call it on inputs. Now, if you need the super special ability, the power, the immense power, in order to the power to destroy. Yeah. Means you have power over something. Okay, so here we go. So if you need the power to make a stateful layer, you need to write your own layer. It's pretty simple. It has an init, so just make sure you call super over here. You save all the goodies that you put in. It has a build. This is pretty important. This will actually go ahead and initialize the kernel after it has computed what the input shape is. Right? It has a call. This is the meat of the layer. The meat of the layer. This is actually what happens. So in this case, this layer is literally it's a dense layer. And then we have compute output shape. So you need to specify all 4 of these. Yeah, you don't need to specify computer output shape, yeah, but generally it's good form to specify all of these when creating your own layer. Okay, I hope you guys enjoyed. This is, you finally know what a layer is. Oh, you're so knowledgeable, so wonderful. We're going to be getting into more goodies after this. We've gotten sort of the most powerful stuff out of the way, but remember, we talked about optimizers before. What's an optimizer? We talked about loss functions and metrics. How do I change those? And then in this layer, there's so much extra. Oh man, I just literally just died. Okay, well, there's so much extra stuff. There's activations, there's initializers, there's more fun. So we're getting into the goodies. So I hope you've enjoyed, and I'll see you next time. As always, it's always a pleasure.